In the previous video we learned a trend of the periodic table, which was ionization energy, and in this video we'll learn another trend which is called atomic radii. And this is defined as the measure of the size of its atoms. So whenever we hear the word atomic radii or atomic radius, we should think the size of the atom. So let's take out the periodic table and see what we can distinguish between these elements. In the previous video, when we were doing the trend of ionization energy, we used the example of sodium and chlorine over here. And we said that as we move from left to right, the ionization energy increases because the number of protons increase, right? So over here it's 11, but here it's 17. So when they increase, the protons increase, the electrons increase, so there's a greater attraction between those opposite charges. And now I'm going to use an example of lithium and fluorine. They're in the same period, right? So I'm going to use the example of lithium and fluorine. So let's write down their numbers. So lithium has 3 protons and fluorine has 9. So let's go ahead and write it down here. So lithium has 3 and fluorine has 9. So let's go ahead and draw the electrons and the atom and see where everything falls. So here's our lithium nucleus, right? And we said that the first ring holds up to 2 electrons. So now we're going to put another shell here. Let me do it in red color again. So here's our color. And we need one more electron to add up to 3, right? So 1 electron goes here, so 1, 2, 3 electrons, and protons equals electrons. And let's draw another atom over here for the fluorine. So here's the red color, and first one holds up to 2, second one is going to be 7, right? So let me change the colors again. So 2 here, 3, 4, 5, 6, 7, 8, and 9. So as you can see that both of these have 2 rings, right? There are 2 shells, 1 and 2. 1 and 2. So the distance from the nucleus to this outermost ring is the same, right? But there is a small difference between these two when it comes to the size. So in lithium there are 3 protons, right? 3 protons and 3 electrons. 3 protons and 3 electrons. So let's fill in our protons, 3 pluses, and we have 3 minus signs, right? So these are 3 negative charge. Over here we have 9 protons and we have 9 electrons. Let's fill in the protons, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we have 9 electrons, right? These are all the electrons. Let me just shade that in really quick. So just like the previous video, we said that protons have a positive charge and electrons have a negative charge they want to attract, right? Because they're opposite signs. So if there is more protons and more electrons, there will be greater charge, right? There will be greater attraction. So looking at our examples over here of fluorine and lithium, we can say that fluorine has more protons, right? More protons and more electrons. So there will be a greater attraction. So I'm going to write more attraction over here. And this one, there is attraction, but when compared to fluorine, there is less, right? Because there's less amount of protons and electrons. So this one is going to have less attraction. So when there is a greater attraction between the protons and the electrons, you can almost think of it as these protons pulling in these electrons. So when this pulling happens, there's a decrease in the size of the atom. So this one is going to decrease in radius or size, and this one, take a look at this one. So over here we said there were more protons and more electrons, but this one we only have 3. So when there is less attraction, right, when there's less attraction, less pulling happens. The protons don't pull the electrons the same way they did over here. And I'm going to write more over here. So more attraction causes more decrease in the radius. So over here we have less protons and electrons compared to this one, and there's less attraction, so less decrease in radius or the size. So using these two examples, let's take out our periodic table and let's post it right here, and let's see what we were doing. So we had lithium right here, and then we have fluorine right here. And we clearly see that fluorine has more protons and electrons than lithium, right? So what is the trend that we can come up with? So let's go ahead and figure this out. So we said that fluorine, there's more decrease in a radius, and this was on the right side, and there's less decrease in radius for the lithium. So we can come up with the trend that as we go from left to right, the radius or the size decreases. So this is the first part, and let's bring in our periodic table again to see another trend. So while this is going across, what is the trend when you're going up and down? So let's use the example again of lithium and sodium, and let's go ahead and do the same exact thing we did up here. So sodium and, well, let me write lithium here. So lithium, we said it has 3 protons, and sodium has 11. So let's quickly draw in the atoms. So lithium nucleus is right here, and here are our electrons, and one out here, and then let's draw one for sodium. So here's a nucleus and one more like this. So let's fill in our electrons. So the first one can hold up to 2, this one 8, and this one is going to be 1, right? So 2, 8, that's 10, 10 plus 1 is 11. So what we see here is that we have a different number of rings, 1, 2, and this one has 1, 2, and 3. So if this right here ends at 2, the size must be smaller than this one, right? So the distance from the nucleus to the valence shell is less, right? So less radius, you can say, or size, less size. So over here we have greater size, because from here to all the way out here is greater than this one. So greater radius and size. So let's take out our periodic table and see what the trend is. So we just did an example of lithium and sodium, and we said as you go down, right, sodium is greater in radius, right, than lithium. So the trend is when you go down on a periodic table from top to bottom, the radius increases. So let's go ahead and write down the trend for this one. So as we go from top to bottom of the periodic table, the radius increases because we're adding more shells, right? So adding more shells or energy levels. So when we add more energy levels, as in this one, right, this one has 3, then the radius is going to increase. So let's combine these two rules we learned here. So as we go from where did I write it? Right here. So as you go from left to right, the radius decreases, And the other one we just learned is as we go from top to bottom, the radius increases. So let's take out our periodic table and let's combine those two, so our arrow we can draw in this direction. So it increases in this direction from the top right corner to the bottom left corner. The radius increases. And notice one thing, that this is an opposite direction of the ionization energy, because in the previous video we said that the ionization energy increases in this direction. So they're the opposites. So hopefully you understand how the trend works for the atomic radius. And this is it for this video. We'll see you in the next one.